Hello everyone. Today we are here to perform the experiment. The name of experiment is to find the voltage regulation and efficiency of single phase transformer. We are here to find the voltage regulation and efficiency of single phase transformer. Here there are apparatus. Apparatus are single phase transformer 1 kVA 220 by 110 volt. 1 kVA is the rated capacity of transformer, as transformer capacity is defined by using kVA rating. Then 220 volt is the primary voltage of single phase transformer and 110 volt is the secondary voltage of single phase transformer. Another measuring instruments we require are voltmeter 0 to 300 and 0 to 150 volts, ammeter 0 to 5 ampere, again second ammeter 0 to 10 ampere, wattmeter 5 ampere 300 volts and 10 ampere 150 volts. Here there are 1 kVA transformer is there. Here 1 kVA transformer is there. You may identify here that there is single phase. Primary voltage is 220 volt, secondary voltage is 110 volt. Then primary ampere is 4.5 ampere, whereas secondary ampere is 8.7 ampere. Here in this experiment we replace wattmeter and voltmeter, and we use analog. We use digital voltmeter and wattmeter in place of analog voltmeter and wattmeter. To explain the circuit, here it is phase and neutral. Both the terminals are present because it is single phase AC supply. Then there is main switch. So here two terminals are there, and the dotted line represents the simultaneous of both the switch can operate at the same time. Then there will be fuse. This is the symbol of fuse. After that, the single phase thermostat, which may be noted as single phase variac or single phase thermostat. Then this is the voltmeter, which is connected for the measurement of you are going to measure this is input voltmeter. You are going to give the 230 volts input, so this voltmeter will help you to identify whether how much voltage you are going to apply. Then from here it is directly connected to wattmeter. Wattmeter is having range 5 ampere 300 volts, so it is MLCP, main, load, common and the potential. So this load terminal is connected to ammeter having range 0 to 5 ampere. Then this will be connected to P1, is the primary first terminal of your primary side winding of transformer. From P2 it is directly connected to wattmeter, potential range, which is known as voltage range, and from here it is directly connected to neutral. So this is the half portion of your circuit. Next portion is S1. S1 is the secondary side. This S1 is the secondary side first terminal of your transformer secondary winding, having rating of 110 volt. Primary side rating is 220 volt, secondary side rating is 110 volt, and the power capacity is 1 kVA. From S1 it is connected to 10 ampere, the ammeter having range 0 to 10 ampere. Then there will be a wattmeter. Again there are 2 points. So M and L is the current coil, C and P is the voltage coil for both the wattmeter. Then there will be a voltmeter to measure the voltage available across the secondary winding of your, or you may say this as induced voltage present across the secondary side of your transformer. Then a load is connected. So here we have used resistive load. Then as far as connection is, your supply is available from the main fuse. So this is the main fuse from where your supply is there. Then here at this location, this is the main, the auto transformer is connected to this cable. So when we switch on the button, your auto transformer will get supply. From first terminal, that is phase terminal, it is directly connected to the wattmeter M. So here the M is connected. It is digital wattmeter and the connections are here. So terminals are given below. So this is M. Then M and C both are shorted. We need to short this M and C because we need to make connection between series circuit and parallel. Next is your L. From L it is connected to ammeter. From ammeter it is connected to primary, that is P1, primary coil first point known as P1. From P2 it is connected to the wattmeter circuit. So here it is connected potential terminal of your wattmeter. From the wattmeter it is again connected to auto transformer, single phase auto transformer. So primary side connection is done. With respect to voltage, you may have to connect in your voltmeter, digital voltmeter, in between M and P, that is potential. So main and potential you need to connect. Now talking about the secondary side, it is connected from S1. S1 is directly connected to ammeter. From the ammeter it goes directly to M. M and C needs to short. From the L it is directly connected to load. So this is your resistive load which is connected. There are n number of switches present over there. After adding one switch, you are supposed to add a single resistive load. So we may add the load and you will see that. Then so L terminal is connected to L of your wattmeter. From N it is directly connected to your potential, and from P2 again S2 is directly connected to again potential, and from there voltmeter is connected in between P2 and your L. In between L and P2 it is the wattmeter is connected to measure the secondary side voltage. Start the experiment. So here we're going to start. So now you may see that the fuse indicator will on. After that we'll on all the digital voltmeter and wattmeter. We'll wait till your digital voltmeter and wattmeter will give 0. Then we will start the mains button, so that your auto transformer will start. So this is how your auto transformer will start now. After that we'll give the supply, that is here the supply is given. So you may see that the supply is increased. We have to increase till 230 volts, 220 volts rated. Why 220 volt? Because our transformer rating is 220 volt input and primary side and 110 volt secondary side. So we have to give 220 volts input. So when we give 220 volts input, approximate 109 point something volt is available, which is known as induced voltage across the secondary. So it is approx 110 volt now, and the wattage is 16 watt. So no multiplying factor is needed for the digital wattmeter, whereas we require to multiply with multiplying factor. Whatever reading we have, that reading should be multiplied with the multiplying factor in case of analog wattmeter, but in case of digital wattmeter it is not necessary. Then you may write the reading. This is first. This thing is known as no load rating of secondary side, that is 110.1. So this 110 is known as no load side. Now this V1 is 220 volts, 220.4. Then I1 here, I1 is 0.5. Then W1 here it is 16. V2 no load voltage, V2 0, we may call this as no load voltage, no load secondary side voltage. V2 0 is equal to 110.2. Then I2 is, see here, I2 is 0 ampere. So here it is 0 ampere. By multiplying this 2 we have 0 watt. Similarly on the secondary side we have 0 watt. Now we are going to add or start the first load. So here by pressing the switch we have the first resistive load have been started. Then simultaneously there are some changes in the reading. So changes are, the voltmeter primary side is 219.3. After that, see here, then your I1 is now 0.8 ampere. W1 is 147 watts, V2 is 109. After that I2 is 1.1 ampere and W2 is 121. Now we are going to add two switches at the same time. In the actual practical you need to add one by one. So now your V1 is 217.56, then I1 is 1.8, W1 is 397, V2 is 106.7, I2 is 3.4, then W2 is 350. Here is I2. Then we are going to add again two switches. So here two switches will on. After that the reading we have is input voltage is drastically reduced because of adding the voltage, adding the load. Because of adding in load, your primary side voltage will be dropped down 216.2. Then I1 is this one 2.9. After that W1 is 630 watt, 629 watt. Then V2 is 104.8, I2 is 5.5 ampere and W2 is 561 watt. Now we are going to add again two switches will on. Then V1 is 215.2, I1 is 4 ampere. इसके बाद में W1 is and V2 is 103.2, ampere is 7.6 and wattage is 755. We will add one more switch. After adding one more switch we will reach up to 4.5. Now why I have added one switch only? The reason behind adding one switch is your kVA rating is 1 kVA, so consider this as 1000 VA. If 1000 VA divided by 220 volts, here it is mentioned 1000 kVA, that is 1000 VA divided by 220 volts will become 4.5 ampere, and in secondary case 1000 VA divided by 110 volt will become 8.7 ampere. So our maximum capacity will reach now by adding these loads. So we have stopped this reading. This is our final reading. Reading is 213.6. Then ampere is 4.5 primary side. Then the wattage is 950. Then secondary side voltage is 101.8. After that I2 is 8.7 and W2 is 837. So here I have written this one. Now we have added the load. Simultaneously we have switch off the load like this. Then the auto transformer, we make this as 0th position. Once we have reached 0, we have to switch off this, and we have to switch off this also. And the last thing is we have to stop the main switch. For the sake of calculation, you need to do two things. One, you need to calculate two things. One is the percentage efficiency, and the percentage voltage regulation. Percentage efficiency can be calculated by using W2 upon W1. W2 is the secondary side voltage and the W1 is the primary side voltage. So when this will become 0, so only iron loss will present. When this is having some value, that is when I2 is present, so that in this circuit, in this experiment, we have two losses known as, one is fixed